This is the first video on our liquids and solids series and is an introduction to the type of solids in particular. This will cover our objective of evaluating different types of solids and determining their properties. There are two major types of solids, crystalline solids and amorphous solids. Crystalline solids are very structured, whereas amorphous solids have somewhat of a random structure to them. A good example would be quartz and glass. They both have the same chemical formula, but quartz has a very ordered structure to it and takes shape, whereas glass is very amorphous and random. When looking at amorphous solids, glass is the most common example. There is considerable disorder in the structure, and the picture I have on the slide here shows that even though the formula is repeating itself, it almost looks like a solution frozen in place. It has a rigid shape, but there's not a lot of order and structure to it. Crystalline solids, on the other hand, have a regular arrangement of components at a microscopic level, and they often produce these beautiful shapes that are characteristic of crystals. The crystals can take on several different shapes, and these shapes are actually dependent on the size and the number of ions that create them. Crystalline solids are ordered due to something called a lattice. Lattice is a three-dimensional system of units repeating in a pattern. The smallest repeating pattern, or smallest repeating unit of the lattice, is called a unit cell. Within the crystalline solids, there are also three subtypes of solids: atomic, ionic, and molecular solids. In the pictures on the side, we see that the atomic solid, diamond, is made of carbon repeatedly covalently bonded to each other in a tetrahedral pattern. The middle picture is sodium chloride. Ions are bonded to each other repeatedly in a lattice. And finally, the picture on the right is obviously a snowflake. Water molecules form a solid in an ordered arrangement of polar molecules. Carbon also makes other atomic crystalline solids, such as buckyballs and carbon nanotubes, both of which are considered in the fullerenes group. In summary, though, the crystalline solids are ionic solids made of ions, are molecular solids made of covalently bonded molecules, and then atomic solids. And these are often made of elements such as carbon and graphite, diamond, or fullerenes, or boron, silicon, and all metals will form atomic solids. Atomic solids are even further divided into smaller groups. These subgroups, depending on the bond that exists in the solid, can be divided into metallic solids, which have delocalized non-directional covalent bonding, and network solids. These are atoms that bond with strong directional covalent bonding that lead to giant molecules and networks. Directional bonding refers to how bonds take on shape and direction, like the shapes that we talked about in the last unit. The third subgroup in atomic solids is group 8A solids, in other words, are group 18 noble gases. They can be attracted to each other through London dispersion forces and eventually will form a solid at very low temperatures. On page 450 in your book, in Chapter 10, there is a table, 10.3, that summarizes the classification of all the solids and includes some of the characteristics that you can find with them. I would suggest taking a look at this and making sure that you understand some of the differences between them. And this concludes the first video for Unit 9.